All right, let's get right into it. Today, we are pulling back the curtain on the magic that happens inside your computer every single second. We're going to break down its most important part, the CPU, literally the brain of your device.
Have you ever actually stopped to think about what's going on in there? It's not just random electricity, you know? It is an unbelievably precise, high-speed dance. And in the next few minutes, you're going to understand exactly how that dance works. So, to make sense of all this insane complexity, we're going to lean on one simple idea. Imagine a chef, but not just any chef, a really, really fast one, working in a perfectly organized kitchen, following a recipe down to the absolute letter.
Okay, so let's properly introduce our main character here, this absolute speed demon of a chef that lives right at the heart of your computer.
That's right, billions with a B. Every single second, the central processing unit, our CPU, is knocking out billions of tiny little steps. The recipe book it's using? That's just whatever program you're running. Its entire job is to read a step, do the thing, and move on to the next one, all faster than you can even blink. But hey, a chef this busy can't do it all alone. An operation this fast and this complex needs a whole kitchen crew, where every single member has one very specific, very important job. So let's meet the team. First up, we've got the control unit, or the CU. This is the kitchen manager, the head chef. It's the one that reads the next line from the recipe and tells everyone else what to do. It doesn't actually do the chopping or mixing itself, but it directs the whole show, sending out signals and keeping the entire team in sync. Next, you've got the specialist, the arithmetic logic unit, the ALU. This is the math whiz of the kitchen. Whenever the manager says, hey, add these two numbers, or check if this thing is bigger than that thing, the ALU is the one that crunches the numbers. It is the calculating brain of the whole operation. Now, this role is so critical for speed. The program counter, or PC, is basically a dedicated bookmark. Its only job is to remember the exact page and line number of the next step in the recipe. The second the chef finishes one line, the PC is already pointing to the next one. There is absolutely no delay. And finally, we've got the support staff. In the CPU world, these are called registers. Just think of them as little temporary holding stations. The IR is like the recipe card the manager is looking at right now. The MAR is a little sticky note with the pantry shelf number written on it. And the MDR? That's the small tray you use to carry an ingredient back from the pantry. Each one has a tiny but totally essential role. Okay, so we've met the chef and the whole crew. Now for the main event. Let's watch them work together to follow just a single step in the recipe. This core loop, this rhythm, is what powers literally everything your computer does. This whole process is called the fetch-execute cycle. And honestly, it's as simple as it sounds. First, the crew fetches the next instruction. Then, the manager decodes what it means, and finally, the team executes the command. That three-step dance is the fundamental heartbeat of all computing. So it all starts with the program counter, our little address book. It says, okay, the next instruction is over here. It gives that address to the memory address register. So basically, the manager just wrote the pantry shelf number on that sticky note. Then, whoosh, the system zips over to that exact spot in memory, grabs the instruction, that line from the recipe, and brings it back, placing it on that temporary tray, the memory data register. And just like that, the instruction has been successfully fetched. Next up, decode. The instruction gets moved from that temporary tray onto the manager's main clipboard, the instruction register. Now the control unit can actually read it and figure out what needs to happen. And here's the really clever part for speed. The instant this happens, the program counter immediately points to the next instruction's address. It is always lining up the next job. And finally, action. The manager, the control unit, starts sending out the orders. Maybe it tells a register to move some data around, or maybe it signals the ALU to do some math. Whatever the recipe called for, this is the moment it gets done. And then, the whole cycle starts right back at the top for the next instruction. Fetch, decode, execute. Over and over, billions of times a second. It's just incredible. But wait a minute. Where are all these instructions and all this data, the recipe and the ingredients, actually being stored? Well, it turns out that location makes a massive difference in how fast our chef can work. So think of it like this. The registers, our little support staff, are located right inside the CPU. They're like ingredients sitting on the countertop, right next to the chef. Access is almost instant. Main memory, or RAM, is like the big pantry down the hall.
It can hold everything, yeah, but it takes precious time to walk over there, find what you need, and walk back. A smart chef always keeps what they need right now on the countertop.
Okay, check out this number, 2 to the power of 16. What on earth could this possibly have to do with our chef's kitchen? Any ideas? It actually defines the maximum size of the pantry our chef is even allowed to use. And here's why. If the memory address register, that little sticky note with the shelf number on it, is only 16 bits wide, it can only write down 2 to the power of 16, or 65,536 unique numbers. That means our chef can only ever find 65,536 unique shelves. The physical size of this one tiny register puts a hard limit on the total amount of RAM the CPU can even talk to. So our chef is lightning fast, and the kitchen is perfectly organized. But there is one last secret to hitting those billions of operations per second. It's not just about working fast, it's about working smart by doing multiple things at the same time. This amazing technique is called pipelining, and it is a total game changer. It basically turns the kitchen into an assembly line. So while our main chef is executing step 5, let's say chopping an onion, the manager is decoding step 6 at the same time, and another kitchen hand is already down the hall fetching the ingredients for step 7. 3 instructions are all in different stages of progress at once. This massively boosts the number of recipe steps you can finish every second.
So from the chef to the crew, the countertop to the pantry, and that brilliant assembly line, that is the secret recipe for how your computer thinks. This whole fetch, decode, execute cycle is happening right now, billions of times, just to draw the pixels on this screen and play my voice for you. It's this constant microscopic ballet of unbelievable precision. So what else is it thinking about for you right this second?